Theorems about roots of polynomial equations.
You don't have to prove theorems.
No,
Is that something?
we're not going to prove this. No. All right. The rational root theorem. Write that down. That's P over Q. P divided by Q test to figure out the possible rational zeros. P is the factors of the constant, Q is the factors of the leading coefficient. All right, one of the questions I could ask you here, the first type of question I could ask you here is to look at the polynomial equation and just list the possible rational zeros. Okay, everybody remembers what rational numbers are, right? What's a rational number? A number that can be written as a fraction. Okay, so your roots and zeros are the same thing. Okay, so basically what we're doing here is a little bit of what we did yesterday. We're going to graph it and look at where it's crossing the x-axis, and those are my roots or my zeros. All right. Now, if you're given a polynomial equation, you can look at this and tell your possible rational roots. So my first question to you would be to list the possible rational roots. P is the factors of the constant. Which one up here is the constant?
3.
The 3. So what are the factors of 3? Plus minus 1 and plus minus 3. Okay? What's the leading coefficient?
X.
1.
1x.
Just 1. Coefficient is a number. What are the factors of 1? Plus and minus 1. Everybody understand how I wrote it? Now if you wanted to break that would be your answer if I told you just to list the possible rational roots or possible rational zeros. You would stop right there. Now if you want to list it out, break them each up, you could say your possible rational zeros are 1, -1, 3, and -3. Okay, those are the only 4 possible rational roots. How many total zeros do I have in this problem?
6. 5. 1.
3.
Get there in 2 more numbers.
3, because the degree is 3. So you have a total of 3. Now you could have 3 rational zeros. All 3 of them could be rational. 1 of them could be rational. 2 of them could be rational. If they're not all rational, then the other ones are either irrational or imaginary, right? All right, so let's find the rational roots. So all I have to do is test 4 of them. Let's do that. Get out your calculator.
So regardless of whether the constant or coefficient is negative, you just put plus or minus.
Correct. Okay. So we're going to go. How did I just do that? All right, go to your calculator. Go to y equals and type in that expression right there.
The x cubed plus x squared.
Yes. Alright, for some reason it's not working up here, so I'll talk you through it. Go to y equals Type that in, x cubed plus x squared minus 3x minus 3. There we go. Clear. Somebody read that to me.
X cubed plus x squared
Hold on. X cubed plus x squared, okay?
minus 3x
Minus 3x
minus 3
minus 3. And hit graph to get an idea of what the graph looks like. And you should get this. Right? Now remember, your possible rational zeros were 1, -1, 3, and -3, right? Here's -3, so I can tell -3 doesn't work. Here's +3, I can tell it doesn't work. -1, it looks like it might work. +1, I can tell it doesn't work. So the only possible rational zero out of our 4 is -1. And if you go to your table, you do see that -1 works. So your only rational root in this case is -1. Alright, so my suggestion is to type it into y equals, graph it, and get an idea of which ones to test. I don't even need to test -3, 3, and 1, because I can see from the graph that it doesn't work. So the only one that works is -1. So the question said, find the rational roots. Your answer is -1. Okay, that's it. You're done.
Can there be more than one answer?
Yeah. We could have had up to 3 of those work. Okay, there are 4
Why not
possible.
all
Huh?
4? Why not all 4?
Because there's only 3 zeros
Oh, yeah.
because of the. Okay.
So what's the point of doing the, whatever root terms or rational terms?
Possible rational roots?
Yeah,
To give you an idea of what to plug into the table.
okay.
You're not just plugging in random numbers.
Alright.
Alright? Next
That's
example.
like, that's not really necessary if you can see the graph. It's
Well,
not like
well, that, the graph just shows you a window from -10 to 10, -10 to 10.
Yeah, finding the.
They could cross somewhere else outside of your graphing window. Yeah,
How do you find the table on your calculator?
hit second graph. Alright, next one. This one says find the roots. So if it doesn't just say find the rational roots, it wants all of them, whether they're irrational or imaginary. So in this case, here's the problem. 2x cubed minus x squared plus 2x minus 1 equals 0. Start out by listing your possible rational roots. What's p? Plus minus 1, right? Because it's the factors of the constant. Q is plus minus 1 and plus minus 2, because those are the factors of the leading coefficient. Everybody with me so far?
Why is there a plus minus 1?
Where? Here?
No, at the bottom.
Because what are the factors of 2? 1 and 2. So if you want to break this up, if I just told you to list the possible rational zeros, you could leave your answer looking like this. Okay, but if we're finding them, you might want to split it up. So my possible rational zeros are 1, -1, 1/2, and -1/2.
How
Yes.
come at the top you didn't put plus or minus 2?
Say that one more time.
How come at the top you didn't put plus or minus 2? Because it was already.
Because at the top, you're looking at this number. What are the factors of 1? Just 1. 1 and 1.
But 2 is a constant too. The number 2.
No. Your constant's 1.
Oh, okay.
You're looking at the last number without a variable and your leading coefficient. So does everybody understand that these 4 are my only possible rational roots? Okay. How many total roots should I have? 3, because your degree is 3. So you start out, so we're going to graph this. Go to your calculator.
Cut it to 1 over 2.
Yeah, that's a division bar. P over Q. Alright, so go to your calculator and type in the y equals. Somebody read that to me again. Make big.
2x cubed
2x cubed, okay?
minus x squared
Minus x squared, okay?
plus 2x
Plus 2x
minus 1.
minus what?
1.
Okay. And hit graph. We know what our possible rational zeros are. What are they? 1, negative 1, 1/2, and negative 1/2. So when you hit graph, the only one that looks like it's going to work is 1/2. Agree? You know 1 and negative 1 don't work just based on the curve. And what were the other ones? 1/2 and negative 1/2. You know negative 1/2 doesn't work. And if you look at your table, mine already has it up here. 1/2 is right here. It does work. So that is your only rational root. So your other two roots are either going to be irrational or imaginary. And to find those other two, everybody good with this so far? To find the other two, we're going to go backwards to synthetic division. Alright, so you're going to take your one rational root, which is 1/2.
Why is it 1/2, and how do you get 1/2 if it's from 1 over 1 plus 2?
From here,
Yeah.
this is 1 over 1 and 1 over 2.
Okay.
You put every number in the numerator over every number in the denominator. Okay, you take your one rational root and use synthetic division. Put the 1/2 out here. Inside we put 2, negative 1, 2, negative 1. And we know our remainder should be 0, or you did something wrong. I know it's a remainder of 0 because I just graphed it. Drop the 2, half of 2 is 1. Add these two, you get 0. Half of 0 is 0. 2 plus 0 is 2. Half of 2 is 1. We do get a remainder of 0. So that proves again that 1/2 is one of your zeros.
When you're doing the calculator, why do you even have to do the graph if you've already found possible zeros?
You don't. You can go straight to the table. It just saves you some time because I knew the only one I needed to test in this one was 1/2. I could tell from the graph I didn't even need to test the other three. Okay? But you can go straight to the table and plug all 4 of them. Now, we know how to write this 202 as a polynomial. 2x squared plus 2 equals 0. And then from there we can solve by factoring. What's your GCF?
2.
Take a 2 out, you're left with x squared plus 1. So from here, you set this equal to 0. If you can't just look at it and figure out the answer, some of y'all may be able to do that. But set it equal to 0, solve. Subtract 1, take the square root of both sides. Your other two results are plus minus I. So your 3 zeros in this case are 1/2 and plus minus I.
What would you do with that too, your GCF?
Nothing. If it doesn't have a variable with it, it doesn't affect your answer. Okay, it's got to have a variable. If it had a 2x with it, then one of your zeros would be 0. Okay? Alright. So that's 2 examples. There are your practice problems.